What is trigonometry? Well, trig just means triangle, whereas metry means measure. So trigonometry is ultimately just the study of the relationship between the set length of the sides of the triangle and the measure of the angles of the triangle. Our focus is using the three most common trigonometric or trig functions: sine, cosine, and tangent, to study the relationships between sides and angles in a right triangle. Before we start getting into each of the trigonometric functions, we first have to correctly label our right triangle. First, we identify the angle that we're talking about. In this example, we'll consider the angle in the bottom left of the triangle. The angle we're considering is always one of the two acute angles in the right triangle, not the 90-degree angle. So here we have our angle labeled, and then we're going to label each of the sides of the triangle as opposite, adjacent, or hypotenuse. Opposite is the side that's exactly opposite the angle we're considering. Adjacent is the leg that's exactly next to the angle we're considering. Hypotenuse is always going to be the side that's exactly opposite the right angle. Now that our triangle is correctly labeled, we're able to consider sine, cosine, and tangent. Sine is abbreviated as sin, S-I-N. The sine of an angle is equal to the ratio of the opposite over the hypotenuse. Cosine is abbreviated as cos, C-O-S. The cosine of an angle is equal to the adjacent over the hypotenuse. The tangent function is abbreviated as tan, T-A-N. The tangent of an angle is equal to the ratio of the opposite over the adjacent. So how can we remember the trig ratios for sine, cosine, and tangent? Well, there's a very popular acronym out there, which is called SOHCAHTOA. SO, which is S-O-H, stands for sine, opposite, hypotenuse, which means that the sine is equal to the opposite over the hypotenuse. CA, which is C-A-H, stands for cosine, adjacent, hypotenuse, meaning cosine is equal to the adjacent over the hypotenuse. TOA, which is T-O-A, means tangent, opposite, adjacent, which means the tangent function is equal to the opposite over the adjacent. All those we've written up here, and we can see S-O-H, so, in our sine, as S-O-H. For CA, we can see C-A-H, cosine, adjacent, hypotenuse. And for TOA, we can see T-O-A, tangent, opposite, adjacent. Now let's try an example. In this example, we're going to find the sine, cosine, and tangent of the x angle and the sine, cosine, and tangent of the angle with measure y. Let's first find the sine, cosine, tangent for the angle measured x. First, we have to label our triangle as opposite, adjacent, and hypotenuse in relation to the angle of x degrees. The side we label opposite is opposite the angle we're considering. The adjacent side is the leg that's next to the angle we're considering. And then the hypotenuse is opposite the right angle. So then the sine of angle x is equal to the opposite over the hypotenuse, which in this example is equal to 8 over 10, which we can then further reduce as 4/5. So ultimately then the sine of angle x is equal to 4/5. The cosine of the angle of x degrees we know is equal to the adjacent over the hypotenuse, which in this example is equal to 6 over 10, which can be reduced to 3/5. The tangent function is equal to the opposite over adjacent, which in this example is equal to 8 over 6, which can be reduced to 4 over 3. So for the angle with x degrees, our sine is 4/5, cosine is 3/5, and tangent is 4/3. So now let's consider the angle of y degrees. Now we have to relabel our triangle because we're considering a different angle. So we'll have to relabel in relation to the angle of y degrees our opposite, adjacent, and hypotenuse. The side length that's opposite is the side that's exactly opposite the angle. The adjacent leg is the leg that's directly next to the angle we're considering. And the hypotenuse is the side that's exactly opposite the right angle. The sine of angle of y degrees is equal to the ratio of opposite over hypotenuse, which in this example is 6 over 10, which can be reduced further to 3/5. The cosine is equal to the adjacent over the hypotenuse, which in this example is 8 over 10, which can be further reduced to 4/5. And then the tangent of the angle of y degrees is equal to the ratio of the opposite over the adjacent, which in this example is equal to 6 over 8, which can be further reduced to 3/4. So then the sine of the angle of y degrees is 3 over 5, the cosine of that angle is 4 over 5, and the tangent of that angle is 3/4. And that's how we calculate trig ratios. Good luck!